Good morning, everyone. Welcome to our last day of the ESI virtual conference. We hope you'd enjoyed it. Again, I'm Marcia Laco, the Environmental Assistance Section Chief with the Division of Environmental Assistance and Customer Service. It has been a pleasure to have you guys with us the last 3 days, and I can't believe it's already Thursday and this is our last day. Hopefully, most of you have joined us already. You know how to use the GoToWebinar toolbox. Just want to remind everybody that you can shrink your control box by hitting that large arrow at the top that hides it so you can see the entire screen when folks are doing their presentations. And that, at least for this morning, you're going to be still muted. Oops. Little teaser for this afternoon. We're going to do something a little different. So it is my pleasure this morning to introduce our first speaker, Terry Albrecht, who will be hosting a panel of some of our ESI members. Terry is the director of Waste Reduction Partners, a technical consulting group of the Land of Sky Regional Council that works in partnership with DEQ and the State Energy Program. The innovative team of volunteer and staff engineers provides waste reduction and energy and water efficiency assistance to businesses and public institutions throughout North Carolina. Since 2000, WRP has provided more than 116,000 hours of technical assistance, helping businesses and municipal clients save more than $22 million in utility costs while improving their environmental performance. Terry is a certified energy manager and a professional engineer in North Carolina with more than 25 years of experience. He holds a bachelor and master's degree in civil and environmental engineering from NC State. And Terry will lead our panel on water efficiency and management, including ESI's members David Auger with Grifols Therapeutics, Steve Street with Corning Hickory, and Stephen Azok with the Fleet Readiness Center East. Terry, thank you for leading this panel this morning.
Thank you, Marcia. It's a pleasure to be here and exciting to have a panel on water. Yesterday, we heard a lot about the Clean Energy Plan, and today we're going to shift gears to talk about in-plant water savings. And looking at the ESI conferences in the past, this is one of the first sessions we have that is specifically on in-plant water efficiency. So it's a topic very near and dear to my heart. The program I work with, Waste Reduction Partners, has had worked in water efficiency strategies for about 20 years. So we're really happy to help moderate and host this session with some great panelists today. Just a word about Waste Reduction Partners. Typically, you know, we'd be exhibiting during this conference, so we just wanted to fill you in and remind you that there's a resource out there. The Waste Reduction Partner Program is a long-running 20-year partnership with DEQ, run out of the Land of Sky Regional Council. Here's a shot of about half of our team. We've got 40 staff and mostly retired engineers, scientists, and architect, other business professionals that are across the state. And they're really there to help you with your sustainable strategies, providing consultation and cost benefit analysis for you across waste, energy, pollution prevention, and water. And we have a long history working with in-plant and in-business water efficiency measures. We've worked with over 160 businesses over the past 10 years, helping them save over 600 million gallons of water and 7 million in savings. Produced a couple of efficiency manuals over that time as well. So we'd love to be a partner with you and assist you on your water efficiency journey. And you can find out more at the Waste Reduction Partner website. So just to help frame our discussion today, I wanted to just remind folks what are the drivers for water efficiency and just briefly cover some things that you may or may not be aware of. You know, water is always on our mind. We know it's of utmost importance, but there's a lot of other driving factors why we should be doing water efficiencies within our own facilities. And first, I just want to mention, so most of you are supplied by potable water supplies coming from your local municipality or regional authority. And many of those entities, especially in large urban places, are under capacity constraints. So when they look at their planning out to 2050, 2060, their demand is approaching their supply. So that's one reason to be focused on water efficiency. And if you look at this chart here in the bottom, about 41% of water use is non-residential, so it's commercial, industrial, institutional. 9% of that is industrial. And if we look at projections from these water supply entities, that the industrial chunk of that pie, that 9%, they don't project that growing very much. So as we as a state grow industrially, we're going to have to use water efficiency measures to help control that portion of the pie. Drought is another huge factor. Our last really large drought was in 2007. That drove new state legislation, that drove lots of new programs across the state and water efficiency. Universities like NC State cut their water use by half after the 2007 drought. Most of our corporations have some sort of sustainable reporting goals through their social responsibility programs. So many folks are reporting. Those goals come to you at your site level, as you know, and then you may complement that with your own developed goals through ISO programs and EMSs. So we see the ESI members had 44 water use goals last year in 2019, and that was second only to the number of energy goals for the 200 or so member sites in the program. We see water supply costs at the potable water supply and sewer all increasing over time. You might be paying about $10 for water and sewer costs at a minimum. We see lots of environmental quality constraints, emerging contaminants. The amount of water we're using all impacts the fragility of our water supply systems and water quality. If we use less water, it's easier to treat that water, especially if you have pretreatment programs. And the wild card is there can be a lot of improvements through production. One more slide here as background before we get to our speaker. These concepts really will lay the foundation for any successful water efficiency program. So, and we're going to hear our speakers talk to these and maybe in a little bit more detail as well. First, you have to understand your water and sewer accounting. Water rates, like electric rates, are complicated. There's fixed rates, inclining, declining blocks. You might have capital fees associated with your meter size, which may be oversized in your case. You might be paying thousands of dollars a month more. And so we have to understand that accounting. We have to understand our baseline. What is our use? Do we need a sub-meter to understand our uses better within our facility? Can we use benchmarks to compare a water use intensity, gallons per unit produced, gallons per gross sales? Look at that internally. It's sometimes challenging to do that in manufacturing, but the external benchmarks can really drive choices in the future for new technologies. Each site should really craft its own water balance. You should have a pie chart and know where all your water uses are through your cooling towers, through production, through cleaning, through kitchens, through domestic uses. You can do that theoretically. You can do that with sub-metering, but that's a starting point for your green team or your project team to work on your projects. And then lastly, I'll just say, be aware not to leave any of the costs out of your cost benefit analysis. In many cases, you might be paying to condition or treat water before you use it. You might be pre-treating that water before it's sent to the sewer. You might be paying sewer surcharges. If that water is heated, if you're using hot water, that might be a factor of 2 to 3 times your water and sewer costs. So lots of things to think about as we go forward. So it gives me great pleasure to go and start to go into our session today and introduce our speakers. And today we're going to have Steve Azok with Fleet Readiness Center, followed by Steve Street with Corning and Dave Auger with Grifols Therapeutics. So first up will be Steve Azok with the Fleet Readiness Center. And Steve, in his current position as environmental scientist, is in charge of EMS and ISO 14000 programs at FRC East, Marcus Cherry Point in North Carolina. Stephen has worked for the Department of Defense for over 22 years and involved in managed different programs over that time. He is also a veteran of the United States Marine Corps. So Stephen, thank you so much for presenting today.
I appreciate it. All right, I'd like to thank everybody for being here today. Good morning. I'd like to start off by speaking about if those who aren't familiar with FRC's mission. We're located on Marine Corps Air Station Cherry Point, which is right outside of Havelock, North Carolina. We border the Neuse River, the Croatan Forest, and Slocum Creek. We are 3,800 civilians, and our main mission is to overhaul aircraft for the Navy, the Air Force, the Marine Corps, and the Army. In late 2016, the Navy came down and said, hey, look, we want to start looking at some of our water goals. We need to start cutting back on some of our water usage. So what we did is we partnered with our sister organization on the Marine Corps side of the house, and we started doing an investigation, looking at the high volume of potable water. What we did is we started looking at some of our industrial sites and what we were doing and what we were discharging, as most of our systems go directly into the industrial wastewater treatment plant. We discovered in doing this that we have a large facility, our naval engine airfoil facility. It's about 420,000 square feet, and it has 27 industrial activities to include stripping, deplating, washing, cleaning. And we were looking at it, and we found out that we were using nearly 79,000 gallons of water per day, and that's potable water. What we did is we partnered with the Marine Corps. We installed some water meters, and we tried to figure out what was the largest source, where the water was coming from. When we identified the activities, we worked with the artisans in those areas to figure out, hey, look, what are some of your normal practices? How do you go about your day? What are you using water for? And what we identified was a lot of the water was consistently running in some of our air scrubbing systems, rinse tanks, and then we have the clean line where when we strip aircraft parts, it goes through and gets that second stage, third stage, fourth stage of cleaning prior to being repurposed and put back on aircraft. And so this was our largest area of water use in this facility. So what we did is we partnered with the Marine Corps, we partnered with the Navy, partnered with our Department of Defense, and we updated our clean line into an automated process. It has automated actuated valves, solenoids, and different pumping systems. Another thing we did is our air scrubbing system that we have in the facility, we made it a closed loop system. So now when the water is running through the system, it's not just going down the drain to the industrial wastewater treatment plant. It's actually a closed loop system, and it's constantly monitored. It reutilizes the water to a point, and then at the point where it can no longer be effective for where it needs to be, that is, at that point, we discharge. And then we went from a continuous overflow rinse process where the tanks were consistently using water to a artisan-initiated hose flushing. So we installed these hose systems in this facility to allow the artisans to control the amount of water that they were using when rinsing the parts and the products. At the conclusion of this, a year later, we identified a 56% reduction. We moved from 79,000 gallons of water per day to 34,600 gallons of water a day. And at this point, we're sitting at a 62% decrease in the amount of chemicals required for the treatment at the IWTP. In 2017, FRC East was given a credit back of $540,000 in savings. To date right now, we've actually reduced our overall water usage at the plant through these constant monitoring, and we're sitting at a 61% reduction of overall potable water use in our industrial process. And it's a continuous effort, and we're continually reducing this. We're trying to get to a point where we're using the least amount of potable water possible. I said we are a large industrial facility. We have a lot of activities. We're very involved with Eastern North Carolina and the state of North Carolina. We've been here for more than 70 years. We've been a steward level member with ESI since 2004, and we are constantly looking at ways to improve our process. At the Department of Defense facility, it's a challenge every day. Some of our facilities are rather old, but with constant monitoring and upgrade, we're moving forward. All right. At this time, I have nothing further. I appreciate the opportunity.
Well, great. Stephen, thank you so much for sharing that incredible progress. And I want to remind all of our listeners that we'll be doing a Q&A session at the end of our 3 panelists. So please type in your questions to your question chat menu, and we'll be posting those at the end. So Stephen, thank you so much for that overview.
Thank you.
Okay, so we're going to transition to our second speaker at this time. We're going to get a little help from our organizers. I want to introduce Steve Street. Steve holds an environmental science degree and is celebrating 30 years with Corning. Steve and his wife have 3 sons and 5 grandkids. I'm jealous. And Steve is a project manager for Project Clean Water implemented at the Corning Hickory Manufacturing and Technology Center, which he's going to be discussing in greater detail. So Steve, I'll turn it over to you. And we are seeing your edit screen at this moment, or your.
Okay. All right. Can everyone see can you see my slide deck now, Terry?
Yes, we can. Your menu's up in the way, but I think it may go away as you click through your slides here.
Okay.
Yeah, perfect.
Okay, good. All right. Good morning, everyone. Hope all of you are well this morning. I'm battling some allergies, so hopefully they won't get in the way too much of this of our presentation. So let me begin with, for those that may not be familiar with our site, we manufacture fiber optic cable and also have the division's research and development residing on campus as well. We've been an environmental steward since 2008. Very proud to be a part of the organization, the ESI organization. And our facility is located in Hickory. Some additional background regarding our manufacturing processes and some R&D activities is that we utilize water for product cooling, which that ultimately led us down the path of water conservation. So the site recognized an opportunity to reduce its impact on the environment by filtering and reusing its processed water. The primary goal was implementing a processed water reuse program that achieved a zero discharge of processed water to the local POTW. So that was the first and foremost goal of this project, and that was approved by our leadership as the chosen goal. The project was established as a Six Sigma design project, and a team was formed that consisted of members from manufacturing, maintenance, process engineering, and also controls engineering. And of course, with any project, it's very important at the beginning to have the right people on the team, and so that you have that expertise that you need for the project to develop and be successful. But also you want to ensure that the stakeholders are, that you have those involved as well. People that have some skin in the game if something doesn't go wrong or if you don't meet their requirements. So it's very important that in the very beginning you identify and get the right people on the team. Some additional goals for the project also included providing clean water, which hence was the name of the project, clean water to the manufacturing processes. That was definitely a requirement. We could not have a negative impact on the manufacturing processes with this project. So we had to make sure or ensure that we met the required process parameters in manufacturing. We also wanted to reduce the site's water usage by 11%. So that's not a normalized value. That's just a total overall reduction. And then also eliminate a safety hazard that existed with the previous draining process. And so the team did a lot of research in different options, and they chose or selected an ion exchange system. And that system was chosen strictly based on the best system that met the site's needs, as we outlined all of those requirements and needs in the design phase. So we ended up connecting all of our manufacturing processes and the applicable R&D lines that utilize water for product cooling to the filtration system. The system provided several benefits to both the business and the environment. As I mentioned earlier, the installed system was projected to provide 11% water reduction. But what we realized after the system was installed is that we actually had a net reduction of greater than 20%. So we far exceeded the original theoretical value that we had calculated for the water reduction. So that was always good when you can do that, when you can exceed. And additionally, the system returned 650 hours back to manufacturing as well. And this was achieved by installing a feed and bleed feature on each process line that essentially allows the water to be turned over every 12 hours. So we operate on 12-hour shifts. So in theory, that water is refreshed or is returned back to the filtration system once every 12 hours without any impact to manufacturing. Manufacturing never sees that process going on. It's all automated. So it's all going on behind the scenes and does not impact the manufacturing at all. And so prior to this system being installed, manufacturing would have to shut down once per week and just do a drain and cleaning of the process systems. And that was because the metals that would leach from the cooling process into the water. So to ensure that we met our wastewater permit parameters, that was a requirement that was placed on manufacturing. And then the system achieved status of zero discharge of processed water. And as such, the city of Hickory rescinded the site's wastewater permit. And of course, eliminating the wastewater permit was a big deal for this site. Definitely made management happy as just one less environmental requirement that we had to meet. So that was, again, a big deal for us. An additional benefit was that the safety issue that I mentioned earlier, we eliminated that. So we had a safety issue that every time that manufacturing, well, I shouldn't say every time, but in a lot of the instances when manufacturing would drain their processed water to the sanitary sewer system, those drain lines could become overwhelmed and actually spill out onto the manufacturing floor, creating safety hazards. So with this new system, it's completely closed loop, and we were able to eliminate that safety hazard. So how does the system work? The processed water is pumped from the manufacturing lines where it drains to the water treatment room. There it's filtered, it's treated with UV light, and then depending on the conductivity of the water, it passes through a series of ion exchange tanks. May or may not pass through those exchange tanks, again, depending on the contaminants that are in the water, at least the concentration of those contaminants. The pump, filters, UV light, controller, all of that's mounted to a skid. So that was provided by the vendor that we chose to provide this system. And as I mentioned earlier, the system is closed loop. So the only loss of water occurs through evaporation and drag out at the manufacturing process lines. And there's really no limit to the number of times the water is filtered and reused in manufacturing. It's a continuous cycle, so water is continuously draining back to the treatment system. It's filtered, treated, and then returned back to manufacturing on a continuous basis. So, of course, with any project, there were a few challenges that we had to overcome. And one was locating a place for the treatment system. In the very beginning, when the project was being discussed and reviewed, and all the analysis was coming together on the cost, one of the first requirements that our leadership placed on the team was that you cannot have any manufacturing space for this system. So you got to figure out how to do all this, but you can't have any manufacturing space. And we all know manufacturing space is a premium, so very understandable. So the team had to get creative. And what we did is fortunately, we had a small utility building, if you will. It was a brick building that once housed a diesel generator, emergency diesel generator that was removed many years ago. And the building was just being used for storage. So what we did is we basically enclosed that building, insulated it, and that became our water treatment building. And then, though, the challenge that we had with that building was that it's very limited in space. And so we only had enough room for one storage tank, 4,000-gallon storage tank, for the processed water. So we had to come up with a way of managing the dirty water coming back from manufacturing, and then also the excess or surplus of treated water that manufacturing may not need. So it's filtering at a predetermined rate, and of course that excess has to go somewhere. So we came up with a way to combine that water into a single storage tank, and worked out real well for us. And then we had a third challenge, is that while we only had 4,000 gallons of capacity for storing water, the challenge was that manufacturing has a much greater volume than that in processed water. So we had to ensure that we came up with a solution that maintained a balanced system at all times. And we were successful in doing that. And so I mentioned the ion exchange tanks, or ion exchange system. So here in this photo, you can see the exchange tank. So we have one carbon tank, two cation tanks, and two anion tanks for treating the water, removing those contaminants. And the system is controlled via main PLC. Each process line also has its own controller or individual controller that is connected to the main PLC. So what this does for us, this allows us to maintain full control over the draining and filling process at each manufacturing line, going back to maintaining a balanced system. So that was a critical in-house design and feature that we added with our in-house engineering team. And then also another benefit of the PLC controlling everything is that, we can also, or it also generates an automatic notification to the maintenance team should a fault occur or something needs replacing. Excuse me, I'm gonna grab a drink of water. As mentioned, those allergies are giving me a fit. So what we've got here is a photo of one of the manufacturing cooling troughs, excuse me, with water after it's been filtered. So you can see the water is very clean in this water trough. And then we also, in the design phase, we wanted to ensure that we looked at energy efficiency and considered that. So what we did is that what we implemented was that, or required, was that all electrical pumps had a variable frequency drive so that we could minimize that energy usage. And then we also, what that filtration system has allowed us to do is eliminated any need to perform any pre-treatment of incoming city water to meet the process parameters. That was another advantage of the system. Project was very successful in such that Corning has installed the next generation at 2 other manufacturing facilities, and they continue to look at expanding at other locations around the globe. And in summary, the project helps the site reduce its impact on the environment through conserving natural resources, reduced operating costs, and increased manufacturing capacity. And then sort of icing on the cake, Something that we're proud of as well is that the project was selected as top project of the year by the Energy Star Partners. So another great external recognition that the team and the project received. So overall, a very successful project for the site and for Corning. And that's all that I have for my presentation.
Well, Steve, thank you so much. That was a great overview of this reuse project and how you did it and those constraints. So thank you for sharing that level of detail. Super informative, and I know we're going to have a lot of questions here at the end. Okay, very good. Well, our third speaker is Dave Auger with Grifols Therapeutics. And Dave has worked for Grifols Therapeutics for 30 years, and the last 16 as the manager of environment, safety, and security. He has a BS degree in general engineering from the United States Military Academy at West Point and a master's of engineering management from Lamar University in Beaumont, Texas. He's been active in the area of sustainability for 25 years. He's a certified sustainable development professional, certified energy manager, hazardous materials professional, and he's also registered professional engineer and a lead accredited professional. So with that, Dave, we'll turn it over to you. You're welcome to put your webcam on as well.
All right, well, my presentation for Grifols is slightly different, not just the overall project of what Grifols has done. We've been an ESI steward since 2017, but to talk about specifically the justification of a project and how you can best take this project to completion by understanding municipal fees that may be associated with it. By justifying or including those municipal fees, you can thus justify it to management and gain their approval. Grifols is a pharmaceutical operation located in Clayton, North Carolina. We have about 1,700 employees, approximately 700 acres of space, 1.7 million square feet under roof. What we do is we take human plasma and we manufacture it to make a product. The site only occupies a small portion of that 700 acres currently, approximately 200 of those acres, but we have a footprint necessary to expand as we see the opportunity presenting itself. The site is of course in Clayton, but our corporate headquarters is in Barcelona. So there's a certain Spanish tint to our activities here and what we pursue. The company has been able to link its history back to the Spanish Civil War and the need for plasma on a battlefield situation. Of course, that moved up into World War II, and since that time, moving to the present, we've been able to take plasma and find a multitude of uses for it around the world. What we do is we collect plasma from the general population. Our collection locations are situated outside college campuses. They're located near military bases. And what we do is take plasma from an individual who's healthy and then turn it into a final product. You may be aware that currently we're also able to take plasma from individuals who survived COVID-19. The antigens that they have in their plasma can be concentrated and used for those individuals who are struggling with that virus right now. We have an operation here in Clayton, and we're doing that at this current time. Not a lot coming out of us because it takes a number of donors in order to come up with a product that can be useful, but we are doing that right now. So that's the background of what Grifols is and what we do. Now the presentation, though, is about the importance of including the one-time water use and sewer use fees when justifying a project. What we had, and we use a lot of water at this location. We use a lot of water for injection, and of course, to get to that point, we have to take city water, go through a reverse osmosis system, and then from there it's distilled, and we have the water for injection for necessary use. Our RO systems are old, and we've had older ones that are effective, but have a tremendous amount of disposed water after their processing. In fact, as high as 40% of the water that goes through many RO units is disposed of. we were able to find a system that, instead of using bisulfite injection, would be able to use carbon filtration to properly process the water through this RO system. By doing that in just one of our 4 RO skids, we would be able to save as much as 9% of the entire city water use from just this one change. And of course, we would decrease the amount of water being sent off-site by 11%. So it seemed to be a no-brainer, and just the tremendous savings that we could gain from this new system, 200 gallon per minute operation. The existing one was 22 years old. It had everything was, of course, operational, but we just had to replace the system, replace the controls, the instrumentation. Because of its poor reliability, we'd be able to just dispose of it and replace it with this new one. I mentioned about the savings in water use and water purchased. The operational savings would reduce the amount of city water we would need, as well as sewer. Instead of having 40% of water for disposal, we would find ourselves between 5 to 10%. The maintenance would be better. The membrane replacement would go away. We even would reduce the amount of employees or maintenance employees necessary to maintain it. The cost was about $1.2 million, and it looked like this is fine. This ought to go forward with no issue whatsoever. The return on investment, a simple one, was 3.6 years. But unfortunately, we got a hold on this. We were told by management, no, that's, of all the projects we currently have in place, water is relatively cheap. Don't go forward with this one, which, as you can see from an environmental standpoint, was somewhat of a shock, because it has such a tremendous benefit to the site for this change. So we had to go back and look at other ways to justify this project. And that justification had to deal with the municipal users fees. Here in Clayton, if you want to request additional sewer usage, it's a $16 per gallon increase. If you want to request additional water, it's a $9 per gallon increase as well. These are one-time fees that add up to, of course, about $25 per every gallon that you need additionally. Now, this site's expanding. This RO system to be put into place would help us to more efficiently use the water we're already purchasing. So if we didn't replace it, we were going to have to find ourselves in just that increase of water use, as well as an increase in sewer use. By being able to include those two fees that many people don't realize are in the future if they just want to continue to operate as they do, and ask the city for more water and the wastewater treatment plant to handle what they're going to send them, are usually just not included. But by our including those two, we were able to show a return on investment of about 1.2 years. Down at the bottom of this slide, you see a spectrum from what's acceptable to unacceptable. Of course, 0.1 years up to 10 years. That cutoff is a mystery in many ways. I know that most engineering departments have an SOP that says a certain percent is acceptable or not acceptable. But when the rubber hits the road in some capital expenditure discussion, that number, that cutoff seems to move from one side to the other. 1.2 was acceptable for Grifols, and from that point we were able to get a go and move forward. This particular piece of equipment has been installed, and it's performing as we stated here. It is a wonderful operation that is resulting in less than 10% disposal of water to the city and to our own wastewater treatment plant. The point here, though, is not to forget these costs. We didn't look at them until after the fact, when we had to go back to the drawing board and figure out how in the world can we get this past the engineering management group and have it added to the projects that will be pursued. That's pretty much the end of my presentation. If you have questions, I'm more than happy to answer them. I'd like to also point out, Terry, that the Certified Energy Manager course spends a lot of time on explaining the importance of getting this ROI in your possession and being able to use it as you move forward, because it's what the engineering group wants to see, and it helps your particular projects move forward. Thanks a lot.
All right. David, thank you so much for that overview of some of the work at Grifols, plus an amazing overview of that project and how you were able to justify it. Here we go. Let me get this back here. So we now are going to move to our Q&A, and I want to encourage all of you to type in your questions, and if I want to invite the panelists to turn on your webcams too, if you've got that, and we can all have kind of a broad discussion. All right, and Stephen Azok does not have his webcam, but he is all there. So again, please type in your question. So one of our first questions we have is Steve Street is for you in Corning, and the question is, how do you define zero discharge?
Well, for us, it was no discharge to the sanitary sewer system. So we don't have any processed water discharge to the sanitary sewer. Now, we do have domestic water, of course, still going to the sewer system, but no processed water. So zero for us means zero.
Great. Very good. I've got a question for Stephen Azok. Stephen, in your evaluation of looking at water use, were you able to, or did you have to use any kind of sub-metering or more defined water monitoring efforts beyond your main meters?
Still the normal meters where we had judged how much water we were sending down to the industrial wastewater treatment plant. When we started this project, we actually installed additional water meters so that we could identify where from the industrial coming in into the line that was going to the industrial wastewater treatment plant. And then we also had sample points set up on those meter lines too, to see what exactly, we knew what was going down to the industrial wastewater treatment plant, but we wanted to see what the levels were from each of the process coming out of the facility.
All right, great. Thank you. Our next question really is posed to maybe all three panelists. And the question is, did any of the systems that were implemented have additional waste or hazardous waste management? Did they help reduce those requirements? And if so, was that considered in the ROI analysis? So Dave, we'll start with you on that.
Yeah, there was carbon filtration, which was replaced by sulfide injection, so there wasn't any hazardous waste concerns in what we were doing here. So not a concern for the ROI calculation.
How about non-hazardous waste?
No, not of a concern that increased over what we were doing, because we were able to actually reduce the amount of maintenance activity for the RO units.
Great. Steve Street, how about addressing that question on waste or has waste impacts and whether they were included in ROI calculations?
Yep, sure. We did include the disposal, or more, not really disposal, but to have those tanks recharged, those ion exchange tanks. We had the tanks analyzed by our vendor. The waste was not hazardous, so we were below all the metal T-clips, T-clip testing for the various metals. So it's shipped out as non-hazardous to our vendor, who then basically just cleans and recharges the media base in those tanks.
Great, Steve, thank you. Stephen Azok, Did you see impacts there to hazardous waste reduction?
We did not, because we didn't change the process. And
oh, could you repeat that? You were breaking up a little bit on your phone, I believe.
Sorry. Process in which the water went to the industrial wastewater treatment plant, we didn't have an overall. We didn't change what we were using. All we did is reduce the amount of water that was going to the industrial waste didn't need to be treated.
Okay, great.
Reduce our overall water.
You're breaking up a little bit on. I'm not sure if that's your phone or over your computer, but anyway, we'll try our best. If you have extra applications, you might want to close them down. Okay. The next question again is back to Steve Street with Corning. Does Corning have to use evaporation or ship any waste off-site related to your wastewater treatment or the remaining wastewater, any remaining wastewater you have?
That's a very good question. So, of course, we've got the disposal for the ion exchange tanks, or again recharging those tanks. We also have the filters that we have to dispose of. Those were also T-clip tested. They're non-hazardous as well. So it did increase a little bit of disposal there for those 5-micron filters. Regarding water from the system itself, any water that we may have to remove from the system for maintenance activities. Now, I'm referring to in the actual water treatment building. That water is pumped back into the storage tank and just filtered and treated and reused. Where we do generate some waste from the process is at the manufacturing process lines, those water troughs and tanks. So there's in most of those process lines, there's a small amount of water, so they still have to clean and drain them periodically. It used to be weekly. That frequency's been extended out several weeks now at a minimum. But when they do have to drain the system and do a deep cleaning of the sides of the trough, there's a small amount of water that is that can't be pumped out. It collects maybe in the low spots of the troughs, and that water is vacuumed into 55-gallon drums, and then we ship that water off for disposal as non-hazardous waste. We could put it back into the system. It's just at this time we've chosen to ship it off-site for disposal.
Okay, great. Thanks for answering that. Steve, we've got another one for you. This is referring to your water reuse system and whether you have a need to add additional fresh water to that system due to evaporation, and if
Yep.
and if that's requiring more fresh water input.
So yes. So as I mentioned in the presentation, the only loss from this system is from evaporation and drag out at the process lines. The system is closed loop. There is no connection to the sanitary sewer. When we have the need for makeup, the city water is actually supplied in the treatment room, and it actually dumps into the tank. So the tank that I showed in one video or one picture, there's a minimal volume of water that has to be in that tank to ensure that we don't create any filtration problems or issues. So when that water level drops below that minimum level, then a valve with the city water makeup is opened, and all this is automatic, and then it fills that tank to a predetermined level, and then that water's treated through the system. Even though it's clean city water, our process parameters, we run a little bit better quality than the city water. Now, that water usage is included in our overall metric where we determine how much savings we've had from that system. So we do capture that. It is metered and is included in the overall water usage for the site.
And that total was 11%. Is that accurate?
Well, 11% was the initial estimated value,
Okay.
but what we've seen is greater than 20% reduction, overall water usage, water reduction for the site.
Excellent. Yeah, fantastic. All right. David, for Grifols, there's another question again about that zero waste goal and whether Grifols has that goal for
We don't have a
zero
zero
water
waste
discharge.
goal.
Excuse me.
Yeah, we don't have a zero water discharge goal. We've looked at that a few times, but mostly it's just a continual reduction. Even our plasma that we purchase, 90% of it is water. So there starts from the very beginning of our raw material, 90% of what we purchase and start with is water. So currently we don't have that. We were considering installing a wastewater treatment plant where we would discharge to the river. And in that discussion, recycling all of our processed water so it could go back through the RO system, WFI system, was discussed. At this time, though, we're not pursuing that.
All right. Well, very good. I'd like to ask each of you kind of a follow-up and kind of closure kind of question on what's next on your horizon for water efficiency or in-plant water reductions or reuse kinds of projects. So Dave, I'll start with you on that. I know you have a lot going on at your site with a lot of different decisions being made right now.
Yeah, the operation, we're expanding our wastewater treatment plant. I mentioned that we considered bringing all the water that's used as wastewater back in through our water processing system. That currently is under discussion but not pursued. Because of the volume of water we use, it would be a wise system to put into place. But currently, that's where we're at.
Okay, thank you. Stephen Azok, you've made such amazing progress thus far on these efforts. Are there any other projects you'd like to share with us that you've done? I know you've done some work with stormwater, and also what's next on the horizon for fleet readiness?
Yes. So the one facility that we did this upgrade to, and we showed this water reduction, it was just the tip of the spear. We have 3 other major facilities within FRC East. One of them being a strip facility where they strip an entire aircraft. And we're looking at what our water reduction could be there, if there's like a reuse effort. But the issue is because we have a military aircraft, we have to be very specific in what can go on and what comes off the aircraft. So, but we're looking at trying to put reduction efforts into some of our other facilities.
And may I ask? I know in some of our conversations you mentioned some of your stormwater diversion efforts, and I think that stormwater entering into processed water, wastewater treatment is a significant issue for a lot of sites out there. And I don't know if you'd like to share any of your progress or your projects there.
Absolutely. So a lot of our sites have the drains go, even external drains or wash areas go directly to the industrial wastewater treatment plant. So when we'd have a heavy rain event or a hurricane, especially with Florence, we'd notice that all that water was going to the industrial wastewater treatment plant. Well, it did not need to be, of course, treated, and we were paying that extra amount going in for the treatments. What we did is we upgraded certain facilities to where stormwater would go to the stormwater conveyance systems, whether it's, ponds, some of the other areas that we have, and take it out of going to the industrial wastewater treatment plant. And that also showed a reduction in the amount of water that was going into the industrial wastewater treatment plant and reduced our overall cost of operation.
Great, thank you. Thanks for sharing that common issue and something maybe to keep your focus on early in the process. All right, Steve Street, what's after a successful RO and reuse project? What do you see next on the horizon? Are there some other projects you have on the sideline?
For water, processed water and domestic water, not at this time. We don't have anything, but you got to keep in mind that over the course of the last 10 years, there have been several other water reduction initiatives that the site has completed. Now, for the division, there is an objective to reduce water usage at each site by I believe 25%, but this site has exceeded that expectation already through other projects such as ice makers, doing some system changes there, low volume flushes or toilet flushes and so on. So there's been a lot of other work going on as well. For this site, it's going to be stormwater, in effect trying to reduce copper and zinc levels in our runoff. So that'll probably be our next water project.
All right. Well, great. Well, you all have taught me a lot to hear about so many great projects from fleet readiness efforts in their process and scrubber water reductions and reuse, and Dave on the incoming water, on how there's savings there through RO improvements, and Steve, what a great overview of an internal reuse projects and kind of the trials and tribulations of making that work with limited space and figuring that out and making the economics all work on that. So we so much appreciate each of your presentation and contributions. Our speakers' information is on the screen here for contact if you have further questions for them, and know all these sessions are going to be recorded, and you'll be getting a link to those from our conference organizer. So with that, I'm going to turn it back over to I guess to Scott Pfister, and or actually we have 2 minutes, so up to our conference organizers if we're going to take a quick break or move into our next session. So again, thank you all to all our speakers.
Yep, Terry, and I think we're just gonna, since it's only about 2 minutes, we'll let Scott get set up and we'll start momentarily. Great information.
Yeah, sounds good. Nana has our next speaker, Nana, has a very prestigious background here. So I think we'll use that time up just talking about him. Thank you, gentlemen, for a great panel. I know I learned a lot talking about water, and we're gonna switch gears here a little bit and talk about energy. So it is now my pleasure to introduce our next presenter, Nana Boughton, EHS Manager at Stanley Black & Decker. Nana currently serves as the EHS Manager at the Kannapolis Distribution Center of Stanley Black & Decker. Passionate about environmental and occupational health and safety issues, Nana has spent the past 10 years in the field, working in various industries, including manufacturing, education, nonprofit, and distribution. He holds a bachelor's degree in chemical engineering, a master's in environmental science, and a PhD in energy and environmental systems. He is an associate safety professional from ASP and has been awarded Manager of Environmental Safety and Health Programs. That's by the MESH, which is completed or organized by Safety and Health Council of North Carolina, and a lead auditor in environmental and occupational health and safety management systems. Originally from Ghana in Western Africa, he moved to the United States in 2013 and has made North Carolina his home. Nana, take it away.
Thank you very much. Scott, can you hear me and see me clearly?
We can hear you and see you, and your presentation is on its title page.
Thank you very much. So I'm very excited to be with you this morning. Like Scott said, I work out of the Kannapolis DC of Stanley Black & Decker. I did write my certified safety professional exam on Tuesday, so I have moved from being an ASP to being a CSP, a certified safety professional. And after 5 hours of brain racking and number crunching, I was able to get the certification. And so sincerely, I dove my hat off to all the EHS professionals on this call who have gone in for their certified hazardous materials management certification and all the other certifications. It wasn't easy for me on Tuesday after 5 hours, so I can sincerely understand what you've all been through to get to where you are. Happy to be here. So this morning, I just want to tell a little story about material handling opportunity charging that we implemented here at the Kannapolis DC and the results that we have seen from that implementation. So a little background about Stanley Black & Decker. We sincerely believe that the right for us to operate in the community is directly linked with how great of an environmental and safety stewards we are in the community. And so for our people, for those who work with the organization, our aim is to always make sure that we are giving them the opportunity and the power to embrace safety, make sure that we are promoting positive habits, and then we transition that into our locations where we are implementing methods all the time through a continuous improvement process to make sure we are reducing injuries. And by that, ensuring that the safe behaviors that are being formed in our associates are also being carried out of here into our homes as well. And our operations are also based on using very sound environmental health and safety management systems. This site is ISO 14001 certified, and we recently transitioned from OSAS 18001 to 45001 as well. And for our practice, we are ensuring that training is always ongoing for our associates so that for any type of programs that we are required to comply with, we have the needed skills to ensure compliance. So for this presentation, I will just give a quick background of the Kannapolis DC and then talk about general material handling in the DC, just give a bit of a big picture of how that happens, and then bring it down to what we are doing at Kannapolis DC, and then particularly talk about opportunity charging, what we have seen so far, and the benefit that we anticipate to see going forward as well. So the Kannapolis DC was built in 1995, and currently it's about 960,000 square foot. At any given time, just based on the number of employees, Stanley tenured employees that we have, contractors and temporary employees, we can have up to 400 employees on site. And the main thing we do here is to receive Stanley Black & Decker branded tools. And you can see some of the brands to the right of the screen: Stanley, DeWalt, Bostik, Erwin, Vidma. These are all Stanley Black & Decker tools. And so we receive those and then we process those to fulfill customer orders. Our customers include Lowe's, Amazon, Home Depot, Walmart, and what have you. Even though the DC is named as the Kannapolis DC, we are actually located in Concord, right on the border between Kannapolis and Concord. So we have that wonderful situation where if we need help at any point in time, we end up having 2 county police departments showing up to assist us before they finally realize that really is Concord that has jurisdiction over our area. But we've been enjoying that, so no complaints there. We are an ESI steward and have been certified since 2015 and currently going through a recertification process. So let's talk a little bit big picture about material handling in a DC. And so when we talk about a DC, we are mainly talking about a building where we receive materials in, process the materials, and then send them out. So the setup is very simple. You have all these receiving docks that allow trailers to bring in these materials. We have material handling equipment. In our case, we use the powered industrial vehicles to allow us to remove or unload materials from the trucks that come in. in the space that you see, the depiction on the slide, the depiction that you see with the arrows, in that space, it is not only moving the product from one receiving dock to a shipping dock, but within that space, you have several storage systems that are applicable that you can use to hold the material until needed. The only time that you would have to take materials from one trailer and then to another trailer to process out is when you do what we call cross-docking, right? And so within that narrow space that we have depicted here would be different type of storage systems, different type of conveyor systems, and in some places, based on the complexity that they have in terms of the automation available, you can have different robotic systems and all within that space between the receiving doors and the shipping doors. Now, if you go through the entire process, the primary activity that happens at a DC would include just receiving the materials, and then you do a put away where you just take the materials and then either put them in storage locations or in picking locations, and then sometimes move them from the storage locations to the picking locations, right? So when we talk about the picking locations, this is where people or machines pick the material that are needed, process them in quantity that are required to allow us to do the shipping, right? So we have different types of picking that goes on. You can have a situation where you are doing a pick to belt, which would include just having a conveyor system and then picking case full load of materials, setting them on these systems, and they go down to a sortation process to where they are supposed to go before processing and shipping. And you can have a situation where, in our case, we use a lot of cluster picking, which would include picking different materials and creating a mixed carton for our customers. And then you finally have what you call shipping, which will be just making sure that the product gets up here on time and to our customers with the right quality and integrity as well. Now, replenishment is just what it is. Once you have storage locations or picking locations assigned to certain products, it's important that once those products are depleted by being picked and being processed for shipping, you replace them with the same items so that those who are responsible for doing the picking, whether it is through robotics or through people, would know exactly where to go to get the product and get it on time. So in talking about what happens in general in the DC, material handling becomes one of the critical components of it, right? It is important that we are able to move materials within short distances, but then move them effectively, because that affects our productivity rate as well. And so some of the things that you would need material handling for would be just moving bulk materials into storage and from storage, and then moving materials from storage to pick locations, needing them to unload and offload vehicles, cross-docking, which would be just taking it off one tractor trailer and then putting on another for onward movement to a customer. And the plan or the aim of being able to do this is, of course, you want to move the material as quickly and as safely as possible within your DC in a very short distance and do so effectively. And it is this effectiveness that my opportunity charging comes in, and we'll talk about that in a minute. So with the different types of equipment that you have for material handling, we are going to focus on just the industrial trucks, the powered industrial trucks or vehicles, but we have different types of material handling equipment, and you can break them up into these four main categories, including the automated storage and retrieval systems, which is more of the robotics and all. The bulk material handling will be a lot of conveyor systems, and we use conveyors here a lot through the facility. And then you have storage and handling equipment as well. So our focus, though, for this presentation is really on the industrial trucks. Some people refer to it as powered industrial vehicles. and some refer to it as powered industrial trucks. These are the forklifts, the pallet jacks, the walkie riders, the order pickers, and what have you. These remain integral in a lot of DCs, especially for the DCs like ours, which does not have a lot of automation, right? And our conversation would be based on the pallet trucks and the order pickers, which are electric vehicles that we use in the facility. Now, the opportunity with using the electric forklifts is the fact that if you have an indoor warehouse, of course, you want to minimize your emissions from any type of vehicles or any type of process that you use to ensure good indoor air quality. And so that's why electric forklifts are the preferred forklifts to use in an indoor environment. Furthermore, they run more quietly than the internal combustion forklifts, which means that if you have processes that do not give off a lot of sound, then you do not have to worry about the hearing conservation program and adhering to that. Now, these electric forklifts are powered by large lead acid batteries. Some of them come way up to 5,000 pounds and more, and these must be charged routinely, okay? And that would require you to make sure that you have a designated area for charging and for changing your batteries if that becomes necessary. So, what is the problem? What's the situation that we are dealing with? Now, conventionally, you have a situation where electric PIVs are usually operated for one shift and then charged overnight. And then you have a situation where after charging, you have to also let them sit for about 8 hours to cool before you use them. And so the conventional charging becomes ideal for when you have a single shift operation. And the way that works would be for you to buy extra batteries so that every forklift would have an additional battery or two, so that whilst one is cooling, the other is in there operating. And what happens is you have a situation where employees are changing batteries between shifts and all that, and you have different possibilities of forklift batteries that weighs 5,000 pounds falling down based on the number of times you are changing them, possibilities for environmental spills, possibilities for high repair costs because now you have a lot more batteries, you are paying a lot more to maintain them. And sometimes if you want to have the best in the system or in the business, you need to have very good battery changing equipment installed, and that can also be expensive. So how does opportunity charging come in here, right? And so opportunity charging is just as it sounds. There is no one best fit solution for all warehouses and for all businesses when it comes to how you are using your material handling equipment. Now, we have a situation where if you are running a multiple shift, like we do with this particular DC, 4 different shifts, first, second, and third shift, and the weekend shift as well, operating almost 24/7, we do not have the luxury of waiting 8 hours to charge a battery and then buying multiple batteries to be able to run the over 100 PIVs that we have and be able to do well when it comes to productivity and when it comes to our desire to be great environmental stewards and to ensure safety as well. So we opted to go and think about this opportunity charging, and that involves being able to charge your battery throughout the shift at any time that you get. And so if you have associates going out on break for 10-15 minutes, these opportunity chargers allow them to put their forklifts down, plug it in, go to break, come back, and then start using them. When that happens, you get a longer use out of the battery for the period and not have to wait till the end of the shift run the battery down completely to 0%, and then charge it all the way back up to 100, right? So that is what opportunity charging is, and that is why we have special charges that allows you to achieve this opportunity charging. So, of course, you have a lot of salespeople that come out and sell us on these different opportunities that come up when they do come up. And this is what you would hear from a typical sales pitch on opportunity charges, that, okay, the batteries take an average of 4 to 6 hours daily to fully recharge instead of 8 hours. If you have multiple shifts, then it becomes a good choice to use. You can get more from your equipment per shift. If you are doing opportunity charging and don't have a lot of batteries around, you are reducing your maintenance cost. Less time and effort will be required to switch out the PIVs or to switch out the batteries. So there's reduced downtime as well for the use of the equipment. There is reduced number of batteries and equipment needed for the work as well. And you may not even need to have a battery changing space. And it can also extend the runtime of aging or older batteries. So this is what you would normally hear from a salesperson when they are selling you on these opportunity charges, which can cost anywhere between $3,000 to $5,000 for one. Now, what the other guys would say, knowing that, of course, not one size fit all solutions are there, they will let you know that indeed you can never have your battery charge up to 100%. It's always going to be between 80 to 85%. You'll still get good use of it, but it's not going to be 100%, and we're to a point where it comes all the way down to 0%. And they have said that it shortens the battery's useful lifetime. Now, we haven't really seen that yet because we are just about 5 years into the project. And as of now, there are no batteries in our system that has run down to the point where we need to replace them, right? So we haven't seen that yet. It's still possible. Now, operators must be aware of what needs to be done when forklift is not in use. And that is an administrative thing that we have to work on. And of course, yes, there are some people that you have to constantly remind that you need to plug your forklift in when you are going on break, right? But we have gone through those growing pains, and now we have a lot more compliance with using or with getting our associates, our PIV operators, to use the opportunity charging for the purpose it is intended for, because if not, then we lose the benefit. And we do have to pay for a battery monitoring system through the company that sold us the opportunity charges. And I think it's an added benefit for us because we're able to tell the capacity of our system and how well it is working from the analytics that they provide to us. So even though we have some that don't believe in its benefits, we have seen something that I think sincerely works for us based on the parameters we are dealing with. So since 2015 to date, we have installed about 50 opportunity charges at a total cost of $150,000. Now, this has been installed throughout different parts of the DC so that based on where you find, which department you find yourself, you are able to use the opportunity charger that is available for you at your department. And so what has been the benefit that we have seen? Now, since 2015 till date, we have actually increased in terms of the value of products coming in has increased by about $5 billion. We have increased our pallet locations. We have increased the number of products coming in. We have increased the number of products we are shipping out. So this is just to go to say that we are doing more. We are doing more. Now, the good thing is now we are doing more with less because the number of electric PIVs have reduced from 114 to 84 today. based on increased productivity and the opportunity charging that we have put in place, which allows us or have allowed us to eliminate some of the PIVs in our system. The lower number of PIVs we have, the better it is for safety, the better it is for maintenance cost. And if we can reduce our PIVs and still increase our productivity and increase our shipping, increase the output from the DC, which is what we are measured on, then it's a win-win situation on both the EHS side and the operation side. And then based on that, we had a lot of lead acid batteries in our system to be able to sustain the number of PIVs that we had doing multiple shifts, which would then require us to switch out batteries. And now that we are not, we've been able to cut down our batteries, our lead acid batteries, from 265 to 149, 44% decrease. Still looking to cut more down because sincerely, we can. We can cut more down because we don't need an extra one for every single PIV. So we are still looking forward to cutting more of those batteries down. But in the past 5 years, this is what opportunity charging has done for us. Now, our electricity cost has also gone down significantly, right? If you look at how much we were spending in 2015 and compare it to 2020, we are using less energy, we are paying less for electricity. Now, not every single gain on electricity use is because of the opportunity charging, right? We've also done a lot of energy efficiency projects, like changing out to LEDs and occupancy sensors as well, and using variable frequency devices on our air compressors and all. So not all of it, not all this gain is as a result of opportunity charging, but yes, we are using less electricity to charge our batteries. And so that has also contributed to the reduction in kilowatt hours spent, used, and the reduction in how much we are paying for it. Now, we are unable to actually quantify exactly how much that is because we have just 1 meter supplying the entire facility. But it goes to show that indeed, getting the gains where you can, like using opportunity charging, and then working on energy efficiency projects can help reduce your energy use in a 960,000 square foot facility like we have running the project that we do 24/7. Okay, so that's also a good thing that we have seen from opportunity charging. And this has been the results. In 2015, we spent $400,000 on electricity. In 2019, we spent way less than that, 38% less than that, right? And we are seeing that same trend this year as well. And like I said, we are doing more. We are doing more as an organization, but we are doing more with less. And that is what efficiency is all about. Another aspect of importance to us is when it comes to reporting on our chemical inventory at the site, both to the state and to the local officials, whereby they need this information to be able to assist the local fire departments whenever there is any emergency on how they handle hazardous circumstances or hazardous situations when they arrive. So all facilities, as you know, are to report on this, and based on the type of hazardous waste that you have, you can have an extremely hazardous substance or other hazardous chemical at your facility. And if you are able to, as an organization or a facility, reduce the amount of hazardous materials, hazardous waste that you have, that's always going to be good for the environment and always going to be good for safety as well. The less you have, the better, right? Reduction is important, and that is what cutting down on the number of batteries that we have at the facilities, lead acid batteries that we have at the facilities, does for us. Being able to cut that down means that we are storing less hazardous chemicals on site, and that can only be good for both the organization and the community around us as well. So the main component of the electric PIV would be lead, about 60% of it, and sulfuric acid. Lead is classified as a hazardous chemical, so you have to report it 10,000 pounds and over. Sulfuric acid is classified as an extremely hazardous substance, and so 500 pounds and over, you have to report it to both your local and state agencies. And what we have done is being able to reduce the lead acid batteries from 265 to 149 has allowed us to store less reportable quantities on the site, which means that we have to report less to the state, which means that if ever there were any emergencies that involve these lead acid batteries, we would have less hazardous chemicals to deal with. So that's also a good thing from the project that we have implemented. And so there you have it. What we have seen is lower electricity consumption. We have less number of spills reported in the past 5 years. We have seen lower cost of maintenance and servicing of batteries and forklifts. And so increased productivity and efficiency based on that. And then our ability to invest in other continuous improvement projects. So all the money that has been saved has been put into other projects that we have done, including, for instance, being able to go to zero waste to landfill, right? We've been able to do that because now we have been able to save from our processes and reinvested in other areas that benefits the environment as well. So I think that for our site, we have seen a benefit from installing opportunity charges. There are a lot of believers at this site in opportunity charges, and based on that, we recommend that to any other site that has the type of complexity we have, having to operate for a long period of time in a facility with this size and using the number of PIVs that we use, 85 and over, would be something that is worth considering. And that is all I have. Thank you very much.
Well, thank you so much, Nana. That was an awesome holistic presentation touching on safety, energy, as well as tier 2. So I think there's a lot that folks can gain from that. We have a couple questions in here, and while I read these off, just wanted to remind folks that to use the chat, use the question feature, write these in, and maybe as this discussion goes on, you might think of one as we go along here. So the first one, there's a lot of points in here, but I'm going to summarize it. Just wondering if you, or actually any of the audience members, you can chime in here as well, but did you, any of the sales folks that came in, did they discuss hydrogen fuel cell or lithium ion batteries? And do you have any experience with those? And if you can speak to that.
So no, I do not have any. We have had some salespeople talk about lithium-ion batteries with us. That's something that we are considering. We haven't gone that route yet, but I do not have any personal experience using those at the site or any other site.
Okay, I made a note here. That sounds like a future webinar opportunity for us.
Right.
That'd be a good one. So the second question here is, what percentage of your energy demand is related to PIVs, HVAC, and lighting? So, of your total pie, what slice does PIV take up?
So that is, like I said, we actually for the facility have only 1 meter. We have not been able to, or we haven't done that calculation, that number crunching, to come up with exactly how much is being used by PIVs and all. And so there isn't a very clear picture of what percentage PIV is, what percentage HVAC is, and what are other systems like the conveyors and all that are using. because we basically look at the bill. There's one bill that comes in for the entire facility. That's something that we can look at, but we haven't done that yet.
Okay, great. So in the origin of this project, did you have any communication with your utility, your electrical utility? And, did that impact all this opportunity charger? Did that impact any of their transformers or any of their wiring, or what were those discussions like?
Yeah, so there was a new transformer that was installed very close to our facility to enable us use the opportunity charges. So there's been an installation of a new transformer in the past 5 years that we've had that project going and added on to the project as well to be able to support the load as well. So yes, we did have those discussions with them. They put in a new transformer close to our facility, and that's what we are using. Now, the amount that we pay at Concord for electricity is pretty low already, based on the fact that Concord City serves as like a middle person for Duke Energy and the customers as well. So we have seen even a greater impact on our energy spend with having a lower cost to pay per kilowatt and having these energy efficiency projects in place to the point where it's been very beneficial to the site.
Okay, great. And I know that you just discussed you haven't done much sub-metering, but I did notice that in your power year-over-year graphs, it looks like 2020 has a little bit more stability to it versus prior years. Kind of look like some of them are kind of a little all over the place. So just wondering if you've experienced that within bills and seeing if it's kind of helping stabilize some of your kind of almost push that peak, doing some peak shaving, if you will.
So the way a DC works, right, is such that you have a situation where over a period of time, like in a year, there are several peak seasons, right? So there are some seasons where quarter end comes every 4 months, right? And so at quarter end, during some of those months, you would end up having to work longer hours, right? To be able to meet the demand of shipments. You have a Christmas period coming up, and when Christmas comes up, there is a lot of demand for a lot of materials to go out of here. And so you see an increase in energy use because we are working our people way longer, or we have to work way longer than we normally do. And so you see those fluctuations coming in during the year for some of the spend that we see for both water, energy, and other things, because you have those fluctuations in the way the business runs over a period of time during the year. Now, this year, we have been more consistent in the midst of the pandemic, working more regular hours because the demand has been fairly consistent with a lot of products required by Home Depot and all for the do-it-yourself projects. And so based on the type of products that we carry as a site, now Stanley Black & Decker has several different DCs, and several different DCs carry different materials. Now the materials that we carry fall a lot in the hand tools group, and since the pandemic hit, it has been very consistent in the demand that is required for DIY materials, and that has seen our business go into a certain pattern of that stability, the hours, the materials, and all. And that could be part of why there is more stability in 2020, because that flow has been more consistent than previous years.
That makes sense. So not only did we get material handling a discussion, we also got a good economic snapshot. You heard it here from Nana. We got a good economic snapshot of what's going on in the distribution world.
Yes. It's been relatively, I don't want to say good, but it has been good for the distribution world because the pandemic and the lockdown has seen an increase. Of course, Lowe's and Home Depot are doing way better now because they have a greater patronage for their materials, like the material that they carry. But yes, hand tools that are used for do-it-yourself projects are selling off the shelves as we talk, and that's because of the pandemic and people wanting to fix things as they stay home for a long period of time.
Okay, great. Nana, thank you so much for the presentation, and thank you, audience members, for your great questions. And with that, I will turn it over to Marcia.
Yeah, so it looks like we're actually early by about 25 minutes. So that's our lunch gift to everyone. Thank you to Nana for all that great information. It's, things you don't think about, how those products that we want in our stores to be ready to pick up, how they actually get there. And thank you this morning for the water panel. It's amazing to learn how, I think there was a show, How Things Are Made. Things you're like, oh, well, how does that happen? And today we learned a lot about how does that happen with our manufacturers. So that is our last presentation for the morning. And we are going to be back this afternoon at 1:30 for our last couple of sessions. Scott's going to take us into the circular economy, and we're going to give you some insight about what the ESI program changes, members, recognition, and then how the grant that supports us from the EPA is changing a little bit for us and how that may affect our members. So everyone will be back at 1:30 and have a great lunch.